on radicals, what we're going to do is we're going to talk about when there are variables inside the square root. And we're going to focus on simplifying. You can't really approximate if there's a variable because there's no number to approximate. So really what we're focusing on is how to simplify radicals or square roots when there's variables inside. Now, I want to remind you guys about what we talked about in part 2, just how to simplify with a number. So I said when you're simplifying a square root, you're looking for perfect square factors to divide out. So let me do a quick example, and I'm going to break it apart and it'll lead into how we're going to do variables. Let's say we want to simplify the square root of 98. So I go off to the side and I do my factor tree for 98. And I say it could be 1 times 98. It could be 2 times 49. Not 3, not 4, not 5, not 6. 7 works. Could be 7 times 14. Not 8, not 9, not 10, not 11, not 12, not 13. So that's our list. Now the biggest perfect square on that list is the 49. 49 is 7 squared. So what I would do if I was simplifying this is I would break it up into 49 times 2, and then I would separate them. The square root of 49 times the square root of 2. Now the answer would be 7 square root of 2, because the square root of 49 is 7. But I'm going to add a step in here, because I think it's going to help you see what we do with variables. The reason that the square root of 49 is 7 is because 49 is 7 times 7. Now when you're doing square roots, if you have 2 of the same number being multiplied together in a square root turns 2 into 1. It says if I'm multiplying 2 of the same things together and I take a square root, it turns into just one of those things. So as we mentioned, our final answer would be 7 radical 2. So you could kind of think of it as if I have 2 7s inside my square root, the square root turns those into 1 outside of the square root. And I think that'll help you see what we're about to do with the variables. All right, so let's do that. Let's switch to variables now. We're going to simplify these 3 radicals with variables. So we'll do the square root of x squared, we'll do the square root of x to the 4th, and we'll do the square root of x to the 7th. And what I'm going to do for each one is I'm going to write them out. Like x squared means x times x. And all of a sudden you go, well, that looks just like my 7 times 7 from before. So the rule was that every 2 of the same thing inside a square root, when you take the square root, turns into just one of them. So the answer to the square root of x squared is just x. And that kind of makes sense because we've learned over the past week that square rooting and squaring are inverses anyways. They cancel each other out. So you should just end up with an x there. All right, let's look at some of the higher powers. Let's look at x to the 4th. X to the 4th is x times x times x times x. Well, again, every 2 of them turn into 1. So what we have here, we have an x from the first 2 times another x from the second 2. X times x equals x squared, and that's your final answer for that one. So the square root of x to the 4th is x squared. All right, let's look at the x to the 7th. Let's go even higher power for x. So this time we have 1, 2, 3, 4, 5, 6, 7 x's all multiplied together. Well, this one right here, these 2 become 1x. These 2 become another, and we're multiplying them all together. These 2 become another, and there's 1 left over. Now, if there's 1 left over, that one stays inside the square root. So what we have is x times x, which is x to the third power, 3 of them all multiplied together, and then you still have that square root of x in your answer. So that's what x to the 7th looks like. When you simplify x to the 7th, you get x to the 3rd times the square root of x. So if you notice some patterns up here, the 2 on top that I did in blue, you had an even exponent, an even powered x, an even number of x's that you're multiplying together. That's why our answer just ended up as x, or x squared. But when you have an odd exponent, you have an extra x left over, an extra variable left over, and that's why you still get that x in the square root as part of your answer. So let's summarize some of that. When you're dealing with variables, every 2 of them inside a square root become 1 outside of the square root. Like that's what a square root does. It takes 2 things that are being multiplied together and turns them into 1. Then what we noticed is if the exponent is an odd number, you still have 1 left over. And that means you'll still have a square root in your answer. If the exponent was an even number, you don't. The square root just kind of disappears, and you end up with just x to some power. So that's basically what we're doing. That's how we simplify radicals with exponents. Now, just like a lot of problems we've been doing recently, if you have a number part and a variable part, just do them separately. So this will be our last example for today. We're going to simplify the square root of 20x to the 5th, y to the 4th, z squared. And I'm going to do this as 4 separate problems. I'm going to do the number part first, I'm going to do the x part second, the y part third, and the z part fourth. All 4 of those things together will give me my final answer. So let's do the number part first. And this is our lesson from before. So I'm going to take my 20 and I'm going to make a factor tree. 20 could be 1 times 20, 2 times 10, not 3, could be 4 times 5, and that's the end of our list because we got back to the 5. So as I look through my list, the biggest perfect square on the list is 4. So I'm going to use the 4 and the 5. I'm going to say the square root of 20, I'm going to break it into 4 times 5. And then I'm going to separate it, the square root of 4 times the square root of 5. I'm going to leave the square root of 5, but the square root of 4 is my perfect square, that's 2. So if I'm just doing the number part, this was a good review from our last day of notes. The square root of 20 is 2 radical 5, or 2 times the square root of 5. Okay, now let's do the x part. So I have the square root of x to the 5th. So maybe I'll write it out. I don't always do this, but I'll do it like I did in the notes before. I'm going to write it out. 1, 2, 3, 4, 5 x's. So these first 2 will turn into 1x. These second 2 will turn into another x. And that last one, since I don't have one to group it with, stays a square root of x. So what I have is x times x is x squared, and I have x squared radical x. Okay, and that makes sense because it was x to the 5th power. Anytime you have an odd number, you get a square root left over. My other 2, my y and my z, I should not have a square root left over because they're even numbers. And let's go ahead and do those. Let's do the y's next. We had y to the 4th power, which would be 1, 2, 3, 4 y's. That gives me a y. That gives me a y. Nothing left over in the square root, so y times y is y squared. All right, let's do one more. We will do z squared. Square root of z squared. Now z squared is z times z. We actually already did this one with x's, but it's the same with z's. So basically the answer is just z. So if you look at these four things, I have one here, one here, one here, and one here. We need to put those all together, and that's going to be my answer. Now what you want to do is put the whole number part together and the radical part together. So I would have from the first one, for my whole number part, I have a 2. From my green one, I have an x squared. From my purple one, I have a y squared. And from my red one, I have a z. Now inside the square root, from the first one I have a 5, from the second one I have an x, the third and fourth don't have a square root, so I'm not going to add anything, and that's my final answer. So you get 2x squared y squared z times the square root of 5x. And I did that by doing 4 separate problems: blue, green, purple, red. I did numbers, x's, y's, z's, and then I put together all the parts. You got to be careful at the end. You know, anything that comes out of the square root on any of the 4 parts, that all goes together at the beginning of my answer. And anything that stayed in the square root from any of the 4 parts, that all goes together in the square root part of my answer.